Alright, so here's our example of the procedure for using one-way analysis of variance to determine if there is a difference, if a difference exists amongst three different data sets. So what we have here is a researcher wishes to see if there's a difference in the fuel economy for city driving for three different types of automobiles: small automobiles, sedans, and luxury automobiles. So our independent variable in this case, which is very important here, is the fuel economy. We have three distinctive independent data pieces. We have a small, we have sedans, and we have luxury automobiles. We randomly sample 4 small automobiles, 5 sedans, and 3 luxury automobiles. So key thing is they're randomly sampled, and the miles per hour for each is shown. So at a significance level of 0.05, we want to test the claim that there is no difference among the means. So our null hypothesis and hypothesis, our null would be is that they are equal. So that's not our claim. Our claim is that there's at least one difference. Okay, so then we'll roll on over. We'll look at step 2. So in step 2, now we need to find our critical values. So remember we said that K is the number of groups or columns. So we have group 1, group 2, group 3, which means our K value is 3. We have a total of 12 values in our data set. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So K is equal to 12. Therefore, our degrees of freedom for our numerator would be K minus 1, which is 3 minus 1, which is equal to 2. Our degrees of freedom for the denominator would be equal to N minus K, and that would be 9. So then what we do is we would go over to table H. So when you're using Connect Math, what you'll need to do is you just click on the table button. If you happen to purchase, and you'll scroll down and find table H, if you happen to purchase your textbook up with the company also, then you can actually go to the back of the book in Appendix A, and inside of Appendix A you'll find table H. So what we have here is we have our, if you look at table H, you'll see that we need to first of all identify that we're looking at the correct significance level. So there are several of them, so we want to choose the one that fits our significance level that was given. From there, we'll see that the first column is our degrees of freedom in the denominator. So that's our degrees of freedom in the denominator, which is 9. So we go down to 9. And then we'll choose our degrees of freedom in the numerator, and that's going to be across the top. And so that's 2. And just like we would on any of the other tables we've used, table E, table 8G, same idea. You find your way across, so they match up. We find out that we have a critical value of 4.26. From there, we're going to compute our test value. So I'm going to make separate videos for that. So at this point, if you were going to use your TI-83, I'll have a link on the homework sheet that will guide you to watching a video for that. If you're going to use Easy Calculation, I'll have a short little video that'll show you how to put it into easycalculation.com. When you calculate your test value for this particular data set, our test value would be 4.83. So now we need to make a decision. So the decision being, are we going to reject the null hypothesis or not reject the null hypothesis? So we had some hard, fast rules, and that if our F test is greater than our critical value, or if our F test is less than our critical value, what would we do? Well, let's recall what that means. If I have a critical value, that I found to be 4.26, remember that establishes this situation right here. So this is my non-critical region, and that means this shaded area right here will be my critical region. So we've been working on hypothesis testing for a long time in this semester, so I think you get the idea of critical and non-critical region. The critical value establishes that cutoff. So in this case right here, we had a test value of 4.83. So that's our F, or F test value. And so in this case here, we can see that our test value is inside the critical region, so therefore we would reject our null hypothesis. So to summarize, there is enough evidence to reject the claim and conclude that at least one mean is different from the others. So we have a significant difference. We see that. If we look at the actual means, we see that the luxury cars is 26, which is quite different than the 35 and the 37 that we saw on the other two cars. So the idea is here is that we can compare many data sets that are all the same type of information, but we can compare them across a broader spectrum. So whether it be fast food and calories per meal at different fast food restaurants, whether it be miles per gallon, just any situation where we want to compare lots of values. And so we're not limited to just two means at a time. We can do this for 3, 4, 5, 6, and so we can really see whether or not we're seeing consistency. And this is once again wrapping up using the one-way analysis of variance to determine whether or not there is a difference amongst the means.